Junior Engineers, Structural Department. Already Neha explained to you about assigning wall load. Once again, I will explain. The loads the load which is acting on the beam is only wall load. So we have to calculate the wall load and apply it on each of the beams. For this, we have to calculate the wall load. We have to calculate the self weight of the wall. We can calculate it by the yes, the equation for calculating the self weight of the wall is we can height of the wall multiplied by width of the wall multiplied by density of the brick which we are using. Here the floor to floor height of the structure is 3 meter. We have to, for getting the wall height, we have to deduct the beam depth from this floor to floor height. So we'll get, we can take 0.4 meter height of the beam. So we'll get height of the wall as 3 meter minus 0.4 meter, which is equal to 2.6 meter. So the height of the wall is 2.6 meter and the width of the wall is, we'll get the width of the wall from the architectural drawing. We can measure it from the architectural drawing. So the width of the wall is, yes, 200 mm, which is 0.2 meter. And the next data which we need is density of the brick, which is equal to 20 kilonewton per meter cube. So we can calculate the self weight as 2.6 into 0.2 into 20. So we'll get 10.4 kilonewton per meter as the self weight of the wall. We have to apply that load on the beam on which the wall is coming. So first we have to select all the beams on which this wall load is acting. Yes. So we have to select all these beams of 20 centimeter width. Yes, you can select it. Here we can see that wall is coming on all beams. This is the beam layout. And this is the wall acting. It's a wall. This is the wall. So from this we can see that yes, on every beam there is wall. So we have to apply wall load on every beam. In the next floor also there is wall on every beam, but we can see that yes, this wall thickness is different from others because it is a partition wall. Its thickness is less. Yes, its thickness is 99.7, which is almost 100 mm. So its thickness is less. So the load acting on this beam will also be different. So we don't need to select it for this load. So we can select all other beams except that. Yes, we selected all the beams. Then go to assign, frame loads, distributed. You have to select it like this, assign, frame loads, distributed. Here we have to select live load, and our load is greater than 3. So we have to select live load greater than 3, and then we can give the load. Here also we can calculate like what is our thick height, 2.6 multiplied by 0.2, which is width of the wall, and multiplied by our density, which is 20 kilonewton per meters cube, and we can enter it. Yeah, we get 10.4 kilonewton per meter as load, and then next apply. Yes, so the wall load is applied on all the beams. Then we can apply the load on this beam also. For this, we have to select this beam, and then we have to calculate the load on that beam, which is equal to, yes, the height is same as before, 2.6 meter, and the width is different. Before it was 0.2 meter, now it is 0.1 meter as it is partition wall. And then density is same, 20. Now, yes, we got 5.2 kilonewton per meter wall load applied. Yes, we got it. Then close it. Yes, there's another floor on which it's a terrace floor on which we know parapet wall will be there on the periphery of this layout. So on this periphery, parapet wall load will be there. So we have to select all the all the beams in the periphery and assign loads on it. Its load will be different from other because its height is different. Parapet wall height will be less compared to the floor height. It will be almost like 1 meter or 1.5 meter. So its load is different. So assign frame loads distributed. We can calculate it as 1 meter. We are considering 1 meter height for the parapet wall. So 1 meter multiplied by thickness is 0.2 meter, and then density 20. So we got 4 kilonewton per meter as wall load. And apply. Yes, we got all the loads. Then close it. So we applied all the loads on the beam. Then next, we can apply the loads on the slab. Beam load is done. Then next is slab load. For the slab load, we have to apply the live load coming on each slab. For this, we have to refer the IS code. It is IS 875 part 2. It is a code for design loads for building and structures. Our structure is a residential building, so we have to select it from the residential building this table. Yes, for residential building, for all the rooms and kitchen, we can give a slab load of 2 kilonewton per meter square. And for toilet and bathrooms, we can get 2 kilonewton as well. And for the corridors, passages, and staircase, the load is 3 kilonewton per meter square. And for balconies, it is 3. So, yes, before applying these loads, we have to identify the slabs from the architectural drawing. Yes. We don't need to give slabs on ground floor because it's the PCC will be coming in this. There will be no slab RCC. There will be no RCC slab coming in this ground floor. There will be only slab at first floor. So we have to just identify these slabs from the architectural drawing. This is the first. This is master bedroom. This is home theater, upper living, toilet, bedroom. Okay, toilet. This is open terrace. Okay. First we have to, yes, this is bedroom. So we have to give load for bedroom in this slab. For this, we have to select the slab. We can select all the bedrooms and kitchen. No, bedroom. Okay. This is bedroom, and then next. Yeah, this is also bedroom. Select these two bedrooms and go to assign. Shell loads. Uniform load sets. Here, we already defined all the load sets. So we can easily assign the load by clicking just bedroom and applying it. Yes. If you just want to check the load, just click on the modify or show definition and click on the bedroom and modify load sets. Yes, here we can see that live load is 2, which as we saw in the code, it's already defined here, and it's given as 2 kilonewton per meter square. But you can see a extra floor finish here. We give floor finish to every element because there will be, yes, in slab there will be floor finishing. Yes, there will be tile work and finishing work on the slab. For this we have to apply a 1 kilonewton per meter square. So there will be floor finish and live load in on the slab. And it's, yes, just click on the previously defined load sets in, select the slabs and select the bedroom and just apply. Next, load for, this is toilet. This is also toilet. Okay. Toilet. Select this toilet and select the toilet. Apply. Then this is living. We can give the living room load here. This is kitchen. So the kitchen load will be here. This is balcony. Is balcony. It's balcony here. For balcony, the load is different as we saw in the table. It's 3 kilonewton per meter square. If you want to check it, just check it by clicking balcony. Oh, balcony. Yes, 3 kilonewton per meter square is already defined here. So it's okay, 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 and just apply. What is this? This is stair. This is staircase. So we can select the slab and then give load of stair. And then this is home theater. Here also we can give the load for bedroom. And this is also part of bedroom. So can give this load. Yes. And on this, what is this? This is also part of bedroom. So bedroom. Okay. Then in next floor also there will be slab. It's terrace floor. It's roof slab. So the roof slab, for the roof slab, the load is 1.5 kilonewton per meter square. Yeah, it is there in the code. Yes. For the flat sloping or curved roof with slopes up to and included in 10 degrees. It's for the roof in which access is provided, we can give a load of 1.5 kilonewton per meter square. So here open terrace. We can select all the slabs and give load for open terrace. Yes, live load of 1.5 kilonewton per meter is defined here. So it's fine. Okay, okay, okay. So all the loads on the beams and slabs are applied. Next is load for, yes, here is missing. It's applied. Okay, next the load for water tank. There will be water tank on the terrace floor. So we have to apply the water tank load also. For this, we need two data. One is what is the capacity of the water tank that will be provided by the client. And also we need to know the diameter of the tank or the area of the tank. If we got the two data, we can calculate the load acting on the slab due to this water tank. For example, if the capacity of the water tank is 1000 meter, 1000 liter, and the diameter of the tank is 1.1 meter, we can calculate the load coming on the slab as load by area. Load the capacity. If the capacity is 1000 liter, the load is 10 kilonewton. For 1000, it is 1000 liter. It is the load is 10 kilonewton. If it is 2000, the load is 20 kilonewton. So for 1000 liter water tank, the load is 10 kilonewton and the area of the tank is pi by 4 into d square. So pi by 4 into 1.1. 1.1 meter. If the diameter of the tank is 1.1 meter, then the area is pi by 4 into 1.1 meter square. We have to divide these two, load divided by area. So 10 divided by area of tank 0.785 into 1.1 square, which is equal to 10.52. First, we have to select the slab on which the water tank water tank load will be acting. If it is this slab, then we have to select the slab and apply water tank and apply. Just check the water tank load is correct or not. Just click it and water tank modify. Okay, it's 10, but from the calculation we got 10.52. We can give the exact value and just click on OK and OK. Yes. Then again apply. Yes, the water tank load will be assigned here. Okay, close. Now we gave all the loads on the structure. Yes, there is one more thing. We have to apply the earthquake load on the structure. For this, you can go to the define menu and then go to load patterns. And there is two. Earthquake will be acting in the two directions, in that direction and also in the y direction. So you have to select both. First, you have to select the EQX and then click on the modify lateral load. Here we have to provide some data. Just since it is in X direction, we have to click this X direction box. All the three boxes should be on tick mark, and then we have to give the zone factor as per code. Okay, there is a code for earthquake loading. It is IS 1893 part 1, from which we have to collect some data, like we have to get the zone factor Z, then we have to get the time period T, and also response reduction factor R. We have to get these three data. It will be we will get it from this code. First we have to find out the zone factor. which will be in the table 2. Page number 6. 16. Yes. Yes. Zone factor 2. Uh, it is classified according to the seismic intensity. It's the structure in Kerala, so the seismic intensity is moderate. So the seismic zone is 3 and Z value is 0.16. So we can give 0.16 as the Z value and the site type is 3. Then next is importance factor I. For this, we can go to the table 6. Yes, importance factor. For this residential building, we can give importance factor 1.5. No, I'm sorry. Important service and community buildings such as hospitals, schools, monument structures, emergency building like telephone exchange, telephone stations, radio stations, railway stations. Okay. For all these building, you have to give importance factor 1.5, and for all other building, it's 1. This description is not included. The residential building is not included in this, so we can give 1. So we gave 1 for this residential building. And then the next factor is response reduction factor, which we will get from table number 7. Yes. For all the special reinforced concrete moment resisting frame, the response reduction factor is 5. So we can give 5 as response reduction factor. And then next is time period, which we can calculate from an equation. It will be in the close sayers here. 7.6.2, we will get the equation. Time period T is equal to 0.09. There is an H which is missing here. The actual equation is T equal to 0.09 H by root D. And the H is height of the building. And D is base dimension of the building at the plinth level in meter along the considered direction of the lateral force. Okay. We can calculate it from the architectural drawing. The height of the building is 6 meter. So T is equal to 0.09 H. H equal to 6. So 0.09 into 6 divided by root D. And this since we are doing it for the x direction, we have to measure the dimension along the x direction, which is it's number. Okay, 9.4 meter. So we can calculate it like 0.09 into height of the building, which is 6 meter divided by root D. Root in D. D is 9.4 meter. In the x direction, D is 9.4 meter. So we'll get time period as 0.1761 second. So T is equal to 0.1761. And now okay. The same should be given in the y direction also, except the time period. Yes, time period also given, but it's different. All other things are same, but the time period is different because the distance in the y direction is different, which is 10.35. So we can calculate the time period as 0.09 into 6 divided by root 10.35, which is equal to 0.1675. 0.1675. We'll click on OK. OK. Okay. Yes, now we apply all the loads on this structure, and the next part is analysis and design part, which will be taken by Sri Lakshmi. Thank you.
Hi, good evening all. Am I audible?
Yes.
Okay. So I'm Sri Lakshmi. I'll be taking the rest of the portion of what Reshma has told. So let's see how to run this model, which has already modeled and all the loads have been applied. So let's see how to run and let's go through the run analysis and its results. So for that, so in one view, you can see the plan view, and in the other window, you can see the 3D view. So in order to make the structure run, here you can see an icon. It's written when you place the cursor, you could see run analysis. So the analysis time depends on the type of the structure. Since this is a very small building, it takes very less time, and the time depends on the complexity of the structure. For a huge building or a multi-story building, it takes more time. And also it depends on the system which you use. For all small types of building, it takes very less time. So let's see how to run this model. So for running, there is an icon, run analysis. So you can click that. So the model has been run, and in the 3D view, you can see the displaced picture. So this is how the structure has displaced for dead load. It's written here 3D view displacement for dead load combination. So in previous classes, the several load cases and the different types of load combinations have been discussed. So here, this structure has been displaced for the load case dead load. Likewise, you can see the displaced picture under several loads. For that, there is an icon show deformed shape. There are several load cases like dead load, live load, wall, earthquake, wind load. Likewise, so if you want to see the displaced structure for live load, just choose live load from this drop down menu, then apply. So this is how it looks under the live load. And if you want to see how it behaves in earthquake, just choose it from the drop down menu and apply. So this is this is how there's a slight difference. So this is how it is behaving under earthquake. And for design purposes, we don't consider any single load case. We'll go with the design load combinations. There are several load combinations, and for the design purposes, we only take the load combination cases. For example, I will show you how the structure is behaving for the 1.5 dead load plus live load combination. Just just click the combination. If you want to see the load case, you can choose the case. And if you want to see the structure for load combination, just click the combination. And from the drop down menu, take 1.5 dead load plus live load and then apply. So this is how the structure is behaving for several load cases and several load combinations. And also there is a start animation icon here. If you click start animation icon, you can see the animated view of the structure. The structure starts animating. So since my version is my version doesn't allow the animation, the window gets stuck. So I'm not showing over the class. So next, let's see. Let's see how to design the structure. So once you run your structure, next we have to go through the design part. So in the design part, you can you can check whether all the members have passed or if all the members are safer. So for that, we have to go to the design option. So in this tab, there are many icons for steel frame design and concrete frame design, composite beam design, and composite column design. So since this is an RCC structure, we'll go with the concrete frame design. So for a design purpose, the first step is to run as I have mentioned earlier. So soon after you run your model, you have to go to concrete frame design. So after the design, we'll check whether all members are safe or not. We'll just see. So this is the plan view and this is the 3D view. So you can see a pink color as well as a red color. So this red color indicates some kind of failure. So we have to look into that. So if all other members looks fine, that means if it's pink in color, all the members have passed, which means all the sections are safe. But two beams indicates red color, which means it is failure. So sometimes if depends on the type of the model or type of the building, sometimes this is a very small structure, so only we have very few failures. But if it's a multi-story building or if the building is sort of big kind of big structure, there will be more than many, there will be more failures, like the column may fail or the more than 10 or 8 more than 10 beams may fail. So it depends. So now we'll see how many beams or how many columns have failed. So if a big structure, we can't count like 1, 2, 3 like that. So for that, there is a shortcut over the concrete frame design and go to the drop down menu. There are many options like view or revise references, select design groups, select design combinations, start design check. Like that, coming to the bottom, we have an option called verify all members passed. So if we click verify all members passed, the system will check the model thoroughly and it let us know if any of the members have passed or any members have failed. So we will just go with verify all members passed. So I'm repeating, the first step after completing your modeling is go to the run analysis, run icon. So once your model is run, go to, if it's a concrete structure, go to concrete frame design, or if it's a steel structure, go to steel frame design. So now I have designed for concrete frame design. So the model has been designed and it shows two failure. And we have to check whether if any other members have also failed. So for that we are doing verify all members passed. So it shows 3 concrete frames failed the design check. Do you want to select that? So if there is a dialog box coming like this, if there is any failure, a dialog box pops up like this. If you have no failure, it shows all members have passed the analysis. So here 3 concrete frames have failed, and do you want to select them? You give yes. And I'm just closing one window. So now we have only the window with the 3D structure. So out of this model, 3 concrete frames have failed, and I don't know which are the 3. I can only see two beams over here. So for that, if you want to show, if you want the Etabs to show only the failed structure, there is one way. Right click in this model space, and there is show selected objects only. See. So there are these 2 beams are connected. That's why it's showing 3 beams are failing. 1, 2, 3. So 3 beams have failed for this under this analysis. And if you want to see the structure as whole again, just right click and select show all objects. So likewise, you can view all the objects. And if you want to particularly see the failed members, you can again go to verify all members past. Three concrete frame failed the design check. Do you want to select them? Yes. Then right click and show selected objects only. Like this, you can see the failed objects. So in this model, only the beams have been failed. So let's see why this beam have failed. And we have to make the design safer. For that purpose, just click this. Just click the beam and right click. So in this in this dialog box, this is concrete beam design information as per IS 456 2000. So it's in the story. The beam is in the story first floor and the beam label is B25 and the beam section is 20 by 30. So in this box, you can see the load combination. It shows under which load combination the beam have failed, and the station location means it's a point on the beam where the beam have failed. And see, this is the top steel and bottom steel. Top steel, this is the area calculated by the system in mm². If we have studied in theory class, like we know how to calculate the area of steel. There is a formula. So likewise, the system automatically calculates how much area it is required for the design. So it is showing as top steel and bottom steel. So in top steel and bottom steel, in longitudinal reinforcement, the section is passing. But when it comes to shear steel, it shows OS 45. So this means the beam is failed. This beam is having shear failure. The beam may have flexure failure as well as shear failure, but this beam is failed for shear. So if the section is not sufficient to support, shear failure occurs. So what we have to do is let's try increasing the section size. So all of you know what is the formula for shear force. So tau V is VU by BD as per IS code. So if the section of the beam increases, that means tau VU by BD. If the depth of the beam or if the B or D, if we increase any of the sections, the shear force may decrease. So we'll just try making the section size increase. Okay. So for that, so now the model is in the analysis mode. So if we have to edit any kind of the features, any kind of the elements in the model, we have to unlock. First of all, we have to unlock. Once you run and once you design your structure, the model gets locked and we can't do any kind of edit to the model. If you want to edit any kind of if you want to delete a beam or if you want to change the size of any of the sections or if you want to edit any kind of loads, the first step is to unlock the model. So here I need to change the section of all the beams which have failed under this analysis. For that, what I'm doing is unlock the model. Before that, do one thing. Don't forget to choose the sections which have failed, because once you unlock your model, we may not know which all beams have failed. So before that, you need to go verify all members passed and show selected objects only. Then you do unlock the model. So the beam has come to its initial phase. So now let's try making. So just right click. And here there is all the information regarding that beam. So you can see the geometry, assignments, loads, and design. So under assignment, the section property B20 by 30. That means this beam sizes are 20 by 30. And all other information regarding the beam will be shown here. So I hope all of you know how to define a section or how to define a material which is already covered in the previous classes or in the initial classes. So in this template, all the beams have been defined, which is already defined here, like 20 by 20, 20 by 25, 20 by 30. So this is we have already defined many kind of sections like beam 20 to 50. Similarly, columns of different sizes are defined here. So it will be much easier if you define uh, different kinds of beams already before completing the model or before the analysis. Because if any of your sections like column or any of your beams fail, you can, you may have any other backup option. You can have now, if my 20 by 30 beam is failing, I can choose any other section from this drop down list because it was already defined. So this beam is 20 by 30. Now I may choose, I am increasing the depth. So I'll go with 20 by 35 or 20 by 40. That will be much more convenient. So I have defined this beam as 20 by 40. And okay. You can simultaneously select. You can select all at once if you want, or if some beams may be of 20 by 30 or some other kind of beams may be of 20 by 50. So now I am here, I am making all the beams which have failed into the same section. So selecting, making it beam 20 by 40. Just check once more. 20 by 40. Okay. Show all objects. So you can see all of your objects in the model. So the beams are still selected. See, this beam and this beams have failed. So now once you complete your edits in your model, again you have to run analysis. And after running analysis, you have to go to concrete frame design. Okay. Still, okay, the other two failure have been rectified. Still, this beam is failing. So this is also coming under shear force failure. Again, you have to unlock. Sometimes if this beam is not joined, also the failure may occur. So I'm just selecting this beam and the adjacent beam. Once again, I'm running. Okay, now the beam have failed as all. Okay, let's go with the older option itself. So if the beam is failing again under shear failure, let me try increasing the section once more. If this beam is under no condition, this beam is not getting passed, it can be some kind of modeling errors, or if the joint is not proper also, the beam may fail because the section 20 by 50 is more than enough for any beam for such a very short span and also such a very small building. So it can also be a modeling error. So I'm just neglecting this beam failure here. So again, verify all members first. If only one concrete frame is failing for the design check, so that it is evident here, only this beam is failing. So likewise, you can make any of your structures safe. And if you properly model, or if you have any kind of joint connection errors, also the failure can occur. So if you model, you have to be very careful in modeling these beams, because for such a short span it should not fail. But I don't know what happened with this beam. Okay, let me check later. Then I'm going to the plan. So here you can see many numbers written like 130, 125. It is showing the AST. That means the area of steel required for this beam section. So uh, all such kind of details will be taken in the next class. This reinforcement, everything comes under the beam. So the modeling and the analysis part of the Etabs ends by this section, and you will be learn more in detail about the Etabs when the section for beams, slabs, column, and foundation comes. And also, sorry, one more thing I have to show is you can see the reactions of the structure which is required for the foundation design. For that, there is a raindrop like option over here. For that, go to combinations and services and display results for these components FZ and MX, MY apply, and just drag down into the base. So in the base, you can see the reactions. With this reactions, we have to design the foundation. So all such kind of topics will be covered later. So the modeling and analysis session ends here. So from next class onwards, we'll be learning about the beams, slabs, and columns, which also requires Etabs. So before that, you need to be very well familiar with the modeling and analysis part. So this is the simplest explanation of Etabs, since this is a very small building. And also the sections of columns, beams, and slabs are more than enough for such a small structure. So it may differ according to the type of building or the type of structure which you model or which you analysis. So this is a simple structure you can learn ETAPS with. So from next class onwards, you will be studying everything in detail. So that's all about today. So I'm winding up this class. Thank you.
Thank you, Sri Lakshmi and Srishma.